In this video, I'm picking up where I left off, so I'm back in the JPA project. I've created the first entity, the artist class, which mirrors the table in the music schema and has an ID and an artist name. Before I can use the entity, I need to do a little setup with my JPA provider. The Hibernate documentation provides samples for different types of setups. In this case, I want to use the JPA version of Hibernate, so I'll be creating a persistence.xml file in a meta-inf folder which needs to be on the class path. The XML properties set in this file will define information to create a persistence context. This context gets created by Hibernate, and you can think of this as a special managed storage place for entities that includes a connection to the database. The meta-inf folder is usually at the root of a web applications folder. In this case, I'll just add it under the source folder of my project for testing. I've included a copy of this file in the resources folder of the project, so I recommend you download that and place it in a meta-inf folder under your source directory to follow along. What I'll do is create the file, which will initially be empty, and then paste the contents in. Either method will work. Selecting the SRC folder in the project panel, I'll select New, File, then enter meta-inf/persistence.xml. I'll paste the XML code in there. The first thing you'll see is that the root node of this XML document is persistence, and there are some namespaces and XML specifications set up there. This is just part of the standard configuration for this type of XML document. Next, a child node is included, and it's named persistence unit. A persistence unit needs a unique name, so I've called this one the same as my package dev.lpa.music, but it can be anything you want there. Next, as part of this unit, I need the properties that will set up the connection to the data. In my case, this will consist of connection details to the MySQL driver. Notice that the property names are specifically referring to jakarta.persistence.jdbc keys. This is to avoid conflict with legacy code, which might use key names like connection.driver as an example. These are the recommended key names for Jakarta's JPA. So the first is the driver, and the value in this case is the MySQL driver that came with the JDBC driver jar file we included in this project in the last video. After this, I've got name and value pairs for the database URL, the username, and the password. Make sure you change the password in this file to be the one you created for your dev user. You might wonder why it's okay to include the password in this file. This file usually will be behind a firewall on a server node with access controlled by the operating system privileges. This means it's less of a concern than hard-coding a password in Java source code, for example. I'll save this and close it. This file needs to be on the class path, so I'll edit the run configuration for my main class. The easiest way to do this is right-click the run arrow in the gutter next to the main method. There, I'll see modify run configuration as an option, and I can select that. From this screen, there's a bit of text on the right of the build and run pane, and it says modify options. I can click that. From the menu of options that's displayed, I'll select modify class path. After selecting this, I want to see the modify class path section on the edit configuration form. I'll select the plus sign on this section's embedded menu bar. Then I'll select include to include a new path on the class path, and I'll navigate to the meta-inf folder under the source directory. And I'll hit OK. I should now see that directory in the class path options. I'll hit OK to close this dialog. Now, it's time to put all these pieces together. Getting back to the main method in the main class, I'll start with a try with resources statement. The first thing I need is an entity manager factory. This serves as a factory for producing entity manager instances. I get this by calling create entity manager factory on a persistence class, passing it the persistence unit name that I declared in my persistence.xml file. In this case, it's dev.lpa.music. This process creates the persistence context that establishes database connections and manages connection pools for efficient resource usage. Once I have this factory class, I can get an entity manager from that object by calling create entity manager on that. Both the entity manager factory and the entity manager are auto-closable, so putting them in the try with resources block means they'll be closed automatically. I'll be adding the code in the block in a moment. For now, I'll complete this with a catch block and print the stack trace of any exception. You might be thinking at this point that this code doesn't really feel simpler than JDBC code. Frameworks usually take a little bit of work up front to get them configured, but you'll see many advantages once you get that work behind you. Inside the try block, I'll get a transaction from the entity manager. It's a good idea to include any changes to a managed entity within a transaction, giving you the opportunity to test the results and roll back if the results aren't what you expect. Once I have a transaction instance, I can call begin on that. Next, I'll call persist on my entity manager and pass it a new instance of the artist class using the constructor that takes artist name. In this case, I'll pass Muddy Water. I'm purposely entering a typo in the name. It should really be Muddy Waters, and that's so I can demonstrate and update it a little bit. Lastly, I want to commit the transaction. In this code, there's no reference to any SQL code and no explicit reference to database into activity. Before I run this, I wanted to open a MySQL Workbench session using the development session I've used throughout this section. In the SQL edit pane, I'll write a select query that will list the artists by descending artist ID. So I'll type select star from music.artists order by artist_ID desk. I'll execute that. My last two artists, two that I added previously, Bob Dylan and Neil Young, and then I'll have the Chemical Brothers with artist_ID 201. Your own list may be a bit different based on the number of times you executed code or if you explored a bit on your own. To get back on the same page, let's delete all the artists we added that have an ID greater than 201. I'll type in a delete statement that deletes from music.artists where artist_ID is greater than 201. I can execute that statement by highlighting it and clicking the lightning bolt. After executing it, I'll delete it from my SQL edit panel here. I'll rerun the select statement, and now Chemical Brothers should be my last artist. To make sure my next ID will be 202, I'll execute a DDL statement to alter the auto increment. I'm doing this because it's likely it's been updated because of the adds and deletes we did over the course of several lectures. I really just don't want any gaps in my IDs, and it'd be nice if we were all on the same page. I'll alter the table music.artists and make auto increment equals 202. I can highlight just this one statement and execute just this, which I'll do now. I'll see that in the action output. I'll remove that statement from my edit pane here so I don't accidentally execute it again. If I did have a record with an ID greater than this number, it wouldn't work, but since my last ID was 201, so this shouldn't be a problem in this case. I'll jump back over to IntelliJ and run my code there. I'll get a bunch of Hibernate messages printed out. About midway down, you'll see the connection properties with the password masked with asterisks and the username devuser. Then you'll see auto commit mode is false, connection pool size is 20. All of this is automatically created and set up for you by Hibernate. What I don't see is any real confirmation that data was inserted. I'll switch back over to MySQL Workbench and re-execute my select query. And there at the top of the result grid, with an artist_ID of 202, is Muddy Water. This confirms that the Hibernate code executed an insert and this artist was persisted successfully. And I didn't have to write a single line of SQL code in my Java code to make it happen. If I change databases, I just need to update the persistence.xml file and that would be it. I'm going to edit this file, so I'll again go back to IntelliJ. I'll open that XML file up and I'll add another property in the persistence unit section. Here, the property name is hibernate.show_SQL and the value is true, which will show the SQL code in the output. I'll save that and rerun my code. Notice the third from the last statement. In my case, the text is a different color from the others. It starts with Hibernate : then it shows me the insert statement that this persist method used. Now I'll have two muddy water artists in my table, which I can confirm by switching to MySQL Workbench and executing that select statement again. I don't really want two muddy water artists in my database, so I'll delete artist ID 203. This time though, I use Hibernate's JPA code to do it. Back to IntelliJ, I'll first comment out the persist statement. Next, I want to retrieve the artist from the database whose ID is 203. I do this with the find method on Entity Manager. This method takes at least two arguments. The first is the entity class and the second is the ID. So I'll pass artist.class and 203 as the arguments. I'll print the instance I get back. Running this code, there are a couple of output statements, again near the last lines of this Hibernate output, that I want you to see. I should see the SQL statement that was used to retrieve the data, followed by the artist entity printed out. And you can see it there, a select statement. This statement is using something called an alias, which is just a temporary name given to the table, but it's selecting the artist ID and artist name from the artist's table based on an artist ID parameter. This is followed by the artists to string method. So that confirms I was able to read artist 203's data from the database using the find method. Now I'll delete this artist using the remove method. I just pass the artist instance to that method. I'll run the code with this change. I've got the additional delete SQL statement printed out after the artist to string. If I pop back over to MySQL Workbench and execute the select, I should have only one muddy water record for artist ID 202. This query confirms that the Hibernate code deleted artist ID 203. I really want the artist's name to be Muddy Waters with an S on the end of water, so I next want to update artist 202. Back to IntelliJ, I'll again edit my code in the main method. This time I'll change the find method to find artist ID 202. Then I'll comment out the remove method here. I'll update the name of the artist object using my setter method on artist. So I'll add this statement after the system.out.println statement. I'll run this. Now you'll see the update statement in the output. I'll switch again to MySQL Workbench and confirm that that change was really committed correctly by again executing my select statement. And there you can see that artist ID 202 has the name Muddy Waters now. Switching back to IntelliJ, I want to look at this code a little more closely. Are you wondering, how did this really work? By just calling a setter on a Java object. How did that get persisted to the database? Maybe you were expecting a call to an update method, for example. Well, the find method not only retrieved the record from the database, it populated the entity artist, but importantly it also set it to a managed state. This means changes made to the entity, the Java object, will get persisted on a commit statement. The Entity Manager identifies state changes between what's in the database and the data in the entity object, and builds appropriate SQL queries to keep the database in sync with the Java object. That's the beauty of using a JPA provider, which monitors and manages the entity state and keeps the data synchronized to the data layer. It's all done seamlessly for you. How would I do this if I didn't want to first query the database? I'll show you that next. I'll comment out the find statement and also the setArtistName method. Instead of calling find, I'll just create a new instance of artist using the constructor that takes ID and artist name. I'll pass 202 an ID I know is in the data and the name Muddy Water. If I run this code the way it is, notice there's no generated SQL statements in the output. Nothing was persisted. I just have my output statement printed there with the new name, Muddy Water, but this wasn't saved to the database. Because I created the artist entity manually, it's not managed by the Entity Manager until I call either a persist or merge method. I use merge if I'm specifying an ID, as I'm doing here. I'll insert a call to merge, passing an artist just before the commit statement. I'll rerun my code. Here, in this output, you can see a select statement was generated by Hibernate as well as an update statement. Hibernate figured out that the current state of the managed entity, when compared to the data in the persistence layer, was different and determined an update was needed. This update took place on the commit statement. I'll confirm it once again in MySQL Workbench running the select statement there. And artist ID 202 is back to Muddy Water without the S on the end. Getting back to IntelliJ, I'll take a minute here to revert those last few changes. So I'll revert the merge method call as well as the statement with the artist constructor. I'll get back the call to the setter and finally revert back a comment line so the code is calling the find method for artist_ID equals 202. I'll run this once again so that my artist is changed back to Muddy Waters. So in this code, we've used Hibernate as our JPA provider to insert a new record into the artist's table using the entity manager.persist method. We retrieve a record with the find method, which required the entity class as the first argument and the entity ID as the second. We deleted a record with the remove method, updating data that was done automatically if the entity was managed when the transaction ended with a commit. You saw that I could use merge to use an existing entity with a valid ID to have it be managed and persisted after a manual creation of the entity. In the next video, I'll go one step further using JPA to explore table relationships, so I'll see you in that next video.